Our next speaker is a leader in the American energy industry. I'm very excited to introduce Ms. Denise Gray, President of LG Chem Michigan Incorporated Tech Center.
Good day to all of you. What a wonderful opportunity to be here to participate in this ARPA activity. When I was invited, my mind went back to a time, probably in the 2008-9 timeframe, where I was at a conference demonstrating battery technology. And additionally, we had our team members who were also participating in an ARPA activity, and it was to demonstrate autonomous driving. And so it was an honor for me to be a part of that activity, talking about battery technology as a part of the energy sector, but also spending some time watching the vehicles go around a field, actually around a course with autonomous driving. And look where we are today. Now we're in 2021, more than a decade later, and we're seeing amazing, amazing progress that have been made on both fronts. I like to talk about the battery technology in specifically because that's the area that I've been working in for the last 15 years. And what an accomplishment has been made by those who are part of the United States Department of Energy, those automaker companies who have been participating, as well as the supply base. We've had amazing year-over-year improvement in cost reduction. We've also had amazing year-over-year improvements when it comes to performance. And that has allowed us to increase the number of vehicles on the road here in the United States and globally when it comes to electrified powertrains. Battery technology specifically has really grown. We've moved from having lithium-ion battery technology in 12-volt battery programs to 48-volt battery programs to full electric vehicle, hybrid vehicles to plug-ins, and also now battery electric vehicles. And again, that spectrum of technology allowing the powertrain to have alternative solutions that allows for better CO2 gains, better fuel economy gains, and quite frankly, more technology and alternatives to provide to the buying customer. All of those have allowed for more technology to be introduced. As we look at the future, we're currently in 2021. As I look towards 2030, 2035, we're seeing amazing announcements by automakers that are increasing the amount of electrified powertrains in their fleets. And that really does bring to bear the accomplishments by the Department of Energy, the United States Battery Consortium, and a number of different entities that have been working tirelessly to understand the technology. Where can it go? Where should it go? And help collaboratively to come together to make it come to fruition. And so we're looking through our crystal ball as we look at in 2030, 2035, will battery technology, battery electric vehicles on the road be 25% of the total volume, 35% of the volume? The answer lies in where we have to stay extremely steadfast in continuing to bring the cost down, continuing to bring more performance to the buying customer, and more importantly, also focus on the infrastructure, bringing charging systems, also thinking about recycling, and all those are the frontier for us to continue to evolve. As I look at the technology that's in place today, we look at lithium-ion technology, but we also look at additional technology that's making the performance increase, such as silicon-based anodes. We're looking at solid-state technologies, and again, the next technologies that will be there. I would really say that those are all because of the collective nature of this business. LG is a part of a network of scientists, of technologies, of universities, of government activities, of automakers coming together. And I think that is where we have to strive. We have to do it collectively in a way that we continue to bring new ideas to the forefront. As I'm thinking back again on the technology that we have today, it comes in different forms and shapes. Cylindrical cells, we have pouch cells, there are prismatic cells, and quite frankly, the next is what we have before us. I always told my manufacturing team, please do not create manufacturing technology around a certain format, because I guarantee you in another decade or so, that form factor will be obsolete. And quite frankly, after a decade and a half, that technology is obsolete, because you as a technologist continue to bring more opportunities, more technology to the forefront, and therefore better technology. And I would say that to be today. We are currently in our third generation of technology development when it comes to battery technology. I'm looking forward to the fourth phase of that, the fifth phase. And it is happening. Again, as I look at 2030, 2035, where global market penetration is looking at 35%, 25 to 35%, we're looking at technology development here in the United States, technology development and manufacturing around the world. And that is really how we have to look at this, as a collective global challenge to bring that technology to fruition. But I have to say, the United States has been on that forefront, and we can continue to be on that forefront of development. We're working extremely close with OEMs, extremely close with advanced labs and the technologist. We've got people in our California facility with technology scouting. We have people on the East Coast with technology scouting, and around the United States, and we will continue to dwell in that area. Two areas that I'd like to really push for attention is in the area of recycling and also in infrastructure. As we continue to develop the technology to have the first life in the vehicles, second life maybe in another application, but at some point in time, we need to continue to think about the recyclability of the technology. How do we extract the good reusable materials so that they can be recycled into the next generation batteries? How do we use that technology to recycle it into the next infrastructure facility? All of those are still yet to be resolved. And I think with the great technologists out and before us, we'll be able to come to that answer. The other area is infrastructure. We recognize that these rechargeable batteries need the recyclability or the recharging ability. And so as we think about where do we dwell a lot at home, we dwell a lot at workplace, and having workplace at home charging ability. The next area we dwell is in our retail activities, be it the grocery stores, be it the clothing stores. And so having rechargeability in those facilities will be helpful as we work as a nation to make sure that rechargeability is in place. And we're going to need private and public sectors to work together to build that recharging infrastructure so that the customer, you and I, will be able to recharge our vehicles wherever we may be. The second set of that is in our buildings. So stationary rechargeability, stationary facilities. And we've got that underway in a number of different places, but it's lagging the automobile industry. And so that's the next area for secondary use as well as rechargeability. And I'm sure all of those activities and ideas are within someone's scope with opportunity to make it better for all of us. Last but not least, as we are on our road trips, and in fact, as the country opens up, we're all thinking about how do we get out on the open road, and we'd like to be able to drive our vehicles from Michigan to Florida, or from Michigan to the East Coast, or at least have one trip from the East Coast to the West Coast and experiencing all the in-between parks and recreation facilities. And so having charging systems along our routes as we vacation or enjoy the open roads across the United States, having the ability to recharge our vehicles through those avenues. Many companies are working collectively to do that. Many automotive companies are working collectively to do that. But can you imagine that the auto companies, the government, the private retail centers, all working together in order to build that network of rechargeability for our buying customers? Last but not least, the balance of performance. How much recharge, how much performance, how much of the battery do we need to have in the vehicle to have that balanced equation? We don't want to be able to carry a battery in the vehicle that has to go more than 1,000 miles, because in some ways that means that we're carrying that along the way. But if we can have a smaller battery, but I have more recharge ability along the way, then that ends up being maybe a better balance of constraints for the customer and therefore for those who are engineering the vehicle. All of these are possibilities when it comes to the next generation battery technology in order for us to have the right constraints on the technology, the right carbon footprint, the right features and functions in the vehicle. And all of those are still challenges before us. But again, I go back to working with the Department of Energy, working with the Department of Energy's ARPA-E programs, as well as the Department of Energy, the United States Advanced Battery Consortium. They've made a way for us in the past. And I'm sure as we all work together collaboratively, we'll be able to find those mechanisms in the future. It's extremely important because, again, 35% of our vehicles being electrified in the 2030, 2035 segment, time segment, will require those. And we as technologists, as manufacturing stewards of our technology, we have to continue to work to bring those to fruition. So again, in summary, ARPA-E, Department of Energy, USABC have been on the forefront of helping to bring the technology to where we are today. As we look to the next decade and the next decade afterwards, the technology has been developing rapidly. The collaboration has continued to gain opportunities in the future. But the technology development and being able to do that technology development here collaboratively with private and public industry is the means for us to do that. The last shout out I have to have is for all of those people who are in areas that are not battery or in energy. We need to be able to retrain the people who are working in, say, the internal combustion engine area, retool them to apply all of their wisdom into this new area. And we can do that with a concentration on bringing new people into this industry in order for us to bring those great ideas that have been available to us in the past to be able to go with us, partner with us in the future for the new technology. I remember many of my colleagues who were working in internal combustion engine, and now they're extremely able to bring that knowledge into the battery technology, because at the end of the day, physics is physics, and being able to bring those people who've been working in those areas, retooling them, retraining them, offering them opportunities to work into this area will help to bring those new solutions into fruition. Please know, those of us that are in the battery technology who have been, who are in here today, are continuing to push for the future to be able to bring this technology to fruition. We're doing that here in the States, but we're also doing it in collaboration with our teammates around the world to bring that CO2 global issue to a better place than where it is today. Lastly, a shout out to those who have been working tirelessly. The mission is not finished. We're at a really good inflection point, but we've got strides to be made as the future goes on. Thank you very much.